Okay, welcome everybody. Tonight is June 7th of 2022. Dallas Personal Robotic Group, Robot Builders Night Virtual, where we talk around the table on all things related to robots and many things adjacent. And once we get done with that, we'll talk about things that are far adjacent to robots. Right? A little bit of housekeeping. We have this contest coming up on the 18th of June. And if you need that last little kick of incentive, those showing up will be able to enjoy club-sponsored pizza. So we'd love to have you bring a robot and compete. Otherwise, just observe and hang out, and that'd be wonderful. And then in October now, we are planning the DPRG Robo Columbus outdoor competition. We moved it from May for the weather, better weather, and also better chance to get some time with the robots, given all the distractions we all seem to be facing at the moment.
Is there a projected date in October, Carl, or has that even been considered?
You know, the default is normally the second Saturday. It'd be a good question for the D list. I think Doug had something in mind with Steve, who would probably host it, but I don't recall offhand.
You might look on the Rev. He might have a date there already. I think he does, but I'm not certain, so I won't vouch totally for it. I'm thinking there's a date there already.
Okay, I'll pull that up and briefly here and post something in. Yeah, he's got Robo Columbus. Yeah, he's it's not there yet. So okay, well that takes us to our main meeting, and for that we have the following queue. We have John G with an update, a brief update. Michael I with a question, and John K with something to show, and then free for all. So, Mr. John, what you got?
Okay, well, as you may remember, I've got a license plate reader camera. I'm working on improving the performance on it. Namely, the problem where during the daytime there's an IR filter that switches out. Switches in to filter out infrared for better image quality. And then at night, I turn on an infrared illuminator and switch the infrared filter out. Problem is that infrared and visible light have slightly different focal lengths. So what's in focus during the daytime isn't necessarily in focus when I operate with infrared at night. So what I've done is add a motor focusing mechanism to the camera so that I can have one focus set in the daytime and one focus set at night. And so here is what I have. So looking at the Raspberry Pi diagnostic screen that I use here to test the focuser, what I have is a menu, and I can go in and I say calibrate. So what will happen is when I tell it to calibrate, it'll run counterclockwise until it reaches the counterclockwise limit, flag that position as 0 on the encoder, then go in the opposite direction until it hits a clockwise limit, and that sets the full range from 0 to however many encoder ticks. So here's an example of it running. Hit the counterclockwise limit. Hit the clockwise limit, and then measured the distance in encoder ticks is about, whoops, I have to stop it here. It recycled. Is about 18. Now I'll have to play it again. I didn't pause it when it hit the end. Okay, running counterclockwise. There's the clockwise limit. There it is. 1,848 encoder ticks.
Don, how does it know the limit? Do you have limit switches?
I have an optical limit switch board, and you'll see here in a second. on the next one, here's what it's doing when I run that diagnostic. You can see on the left-hand side of the screen, there's this little linear gear that the motor gear is between the linear gear and the focusing gear on the camera. And then at the upper left, there's 4 optical detectors, 4 optical limit switches, where it's just that gear, that linear gear is interrupting one of 4 of those switches. So I can find a precise position for the end of the gear. So here it is running. See, it runs all the way to the top of and then goes all the way down to the bottom detector. And that's the whole calibration cycle right there. So in terms of results, if you look at some of the images I've captured in the house, what I did was put, like you can see, I put this, I don't know if you can see it, I have to zoom in, put this eye chart about 25 feet away in my house and use the focusing mechanism to figure out where the focus of the visible and infrared is. So this is visible light without with the IR filter in. And if you look up close, whoops, yeah, there's the up close image. Visible light with the IR filter in. That's the best focus I could get at a reading of 1,500 encoder ticks. But at 1,500 encoder ticks, if you look at infrared with the infrared filter out and infrared illumination, you can see that's not terribly focused very well. You can barely read the E. And if I zoom in up close, this is what it looks like. So this is with visible focus, but IR, it's not in the same focus. If I change the focus mechanism down to a setting of 250 encoder ticks, I get this. So in infrared, down at 250, much better focus. So, but if you're at 250 and if you're at the, I'm sorry, that's something here. If you're at the 250 focus, then I lost my screen here. If you're at 250, then when you go to infrared, I'm sorry, when you go to visible, this is what it looks like in visible. In visible light, you're out of focus again. So there's in focus at visible, there's out of focus. In focus, out of focus. So there's a significant difference in the focal length that I've determined from doing this little experiment. But now I've got something I can use in this new version of my camera. Well, I got a new box to print out and put together because now I got to fit all that stuff inside the same a different size box. So that's it.
John, that's really cool.
Well, it was really interesting to see. I knew there was a difference in the focal length. I didn't realize it was that drastic.
It makes me, I was thinking as you were showing that you know, when they design RF antennas, they do them to handle broader or more narrow ranges of frequencies effectively. And I was just imagining within my very cloudy brain as to I wonder what could be done to optical systems to have similar effects of broad range focusing capability as to what can be done for RF antennas.
And one question that might come to mind is, well, you know, I spent an awful lot of effort put all sorts of mechanisms in there that you would think somebody sells a product like this. Well, they don't. If they do, it's got to be something really expensive.
Huh. And so it's just the same lens, and you have some IR filter for day.
Yeah.
To take out for night. So there's no visible energy at night, but there's plenty of IR energy that without the filter, it hits the sensor. So,
Well, and I also have the IR illuminator that I have that's got a lot of IR LEDs on it to supply illumination.
all right.
License plates reflect those very well.
Yes.
Well, that's cool. Thanks for showing.
No problem.
And some of your demo videos are a little hard to see. Is it possible you could put the link on the web? Are they public?
Oh, they're on YouTube, so I can link them in the chat.
Cool. All right. Yeah, in case anyone wants to see the detail, because those are neat examples just to show the difference. Okay, cool. I think next in line, Michael, you had a question from Orbit somewhere there.
Yeah, I better hurry before I have to. All right, so I'm thinking about getting in the four corner competition in Roborama.
Nice.
Okay, so but I'm kind of I'm under the gun here to get a robot ready. So I've got an old my old line following that I have, the motor and it has the drive and well, it doesn't have the motors, but it has everything on it, battery holder. And I'm thinking about using these cheese, those cheesy. I had one of these in a box, right?
Right.
Y'all seen those, $15 or whatever. But I was thinking about using these motors and wheels with this encoder on it. With this type of, is that a waste of time? If I try to get one done, expediently, is that a waste of time for what we're doing here? Is that too? Do you think that is it one waste of time trying to get one of them together? Because I got everything there. All I have to do is, mess with the code because it's all built.
It's never a waste of time. You can always show this is what this hardware is capable of. But if you've got a working robot with encoders and stuff, and you just have to write some code to I'd do that.
Okay, good. And I also have another thing. My granddaughter, which is 9, is a little curious about this, and so I was thinking about if I get this going, we can put her one together real quick, and we can kind of let her get in that competition. Would that be fine?
That'd be more fun. That'd be outstanding.
Yeah, let's see if she might get bored after 10 minutes, So I don't know, but she's the one that mentioned it. So if I get this going, I'll just kind of duplicate it on another robot and see if we can get her going on that.
So anybody know what are the pros and cons on optical encoders versus Hall effect encoders?
These opticals, well, these you can't do. What do they call it? Quadra. You can't tell which direction it's going.
Well,
It doesn't know which direction it's going. It just sees impulse.
Michael, I found, and you probably have found also, that for a lot of things it really doesn't matter because you know which direction the motor is going by the signal that was sent to it. And when if you go through zero real fast, you might be wrong for a couple of samples, but even that is probably ignorable.
Okay.
Well,
Go ahead.
That's the nice thing about the Palolo encoders that they sell with their motors. Those are Hall effect encoders, and they do give you you can determine direction because you've got two signals coming in out of phase coming out.
Well, I'll do that later on, but right now the Roborama is like a week and a half from now. So
11 days.
Yeah, so I got to get something going real fast.
but it's possible, I would say.
So I've got everything for that to do that, but
And you really could probably even get Gretsch if you really need it with that. I mean, with the light, you have to have two separate lights, basically. So I really think it actually could be done.
all right.
Well, and as we
Without.
talked about last week, you could really run Foursquare if you have a place to set up and test. You could really do it all with just timing. You could do it without any encoders at all. Just
Well, how do you know the-
Well,
try to
I
drive.
would, I would disagree with you on that part a little bit, but
You
I
won't
wouldn't,
be,
because I've done it.
you won't be the best robot there, but yeah, I've done it. You
Yeah.
drive in a straight line for a certain period of time, and then rotate for a certain period of time.
yeah,
Hope, hope that's 90 degrees.
but the key is going straight without encoders.
So
And
it's
even
crooked.
with encoders, it can be a problem. But
Yeah, but you want to be positive, right? Do
okay,
do what you can with what you got.
oh yes, I
Because-
agree with that.
Because if nothing else, it's a good effort, and it can often lead to amusing and sometimes successful results.
And
Yeah, if you get it working with timing, you also have laid a good foundation for why it is you need something like encoders, or even better, coders and a gyroscope.
and I would even
And
say,
IMU, you start to see what, but if that means you can get 95% of the way there without it, but you can't get the last 5% there.
and you might discover that the encoders don't need to be all that accurate as long as you can get 5 ticks and
Yeah.
3 inches.
Well,
So you might actually
What-
be better off with
So
less
let me,
encoder.
I got some more questions about that Foursquare. When we set the robot down, where do we set it down inside the perimeter? Is it like in the middle of two? Where do we set the robot to start?
You have to read the instructions, but I think it's outside, and it has to go around basically a 10 by 10 square.
Goes around the outside of the perimeter.
I think so, if I remember right.
It goes outside, and you get a choice. You get to choose where you put it down.
Oh,
And the key is it's basically how close can you get back to that spot?
okay.
Wherever
So
that spot is.
another question is, we don't know how big that perimeter is. I don't think.
I would
According
say
to-
10 by 10, but
okay, I just pasted
read
the
the
link
instru-
with
yeah.
the rules as they are.
It says
So,
8 to 15 foot on the website.
okay.
On that PDF file, it says 8 to 15 feet.
well, yeah.
So there's nothing set yet, but you go the outside of that perimeter, and then try to make it back to the
The spot.
starting point.
Right.
Okay.
And you don't have to drive in a straight line, right? It could be a circle as long as you stay outside the cones.
That's
Oh, really?
the way I think it reads. So yes.
I thought it kind of had to go to one point, get as close as you can, and then hang a right angle on it and go to the next point. It doesn't matter, just so you kind of get back to your starting point.
That's right.
But you
Okay,
might have
well,
to worry about how close the square is to a wall or a table or something else.
Participant, observant.
Participant. Yeah.
Yeah.
You have to stay outside the cones. The 4 corners are marked with cones, and not hit anything else.
Right.
Well,
I mean,
I
technically
think
it says-
that the rules state that there has to be 3 feet clearance around whatever square has been designated. So yeah, there may be a wall, but you can count on like 3 feet, I think it says. So in your case, if you wanted to set it up and say you do it for a larger area, like 10 to 12 feet, and Doug or whoever sets up the course sets it up at 8 feet, you can still do a 10-foot square. It's just a matter of how close you come back to where you started.
Okay, that sounds actually a lot simpler than what I was thinking in my head of how it was going to be done. So I was kind of thinking like you had to like you had to go to the point and kind of get real close to it, and then make a right angle and then go to the next point. But
No,
Yeah.
it's exactly what Scott said. The only point that you have to do that is the last point, which
Okay.
is the first point.
yeah, it sounds doable.
Basically, your score is how far away you are from that first point.
Okay. So actually, like you said, it'll be fun to see how one of these $12 robots do.
Yeah, $12 robots with low res encoders, optical encoders. Yeah.
I think there was a team a couple of years ago that with one of the Lego robots, they got within a couple of inches.
Yeah.
And that was one of the kids teams.
Okay,
Yeah,
My,
that's
my,
possible.
my son got within 1 inch using a Lego robot about,
Oh, maybe that's who it was.
that was probably 10 years ago. I doubt
Well,
he
no, this
remembers.
was some girls.
Yeah, cool.
But yeah,
Yes.
I mean, it's doable for sure.
They scored.
good. I'm fired up now.
Hey, Pat, do you remember
Hello.
what size? Because you ran the virtual one already from your end, right? Do you remember what size you used?
I used an 8x8 square, and so I stayed on the outside of the 8x8 and ran the competition. And I won't tell you how I did because I'll let
that's-
guys announce that.
I didn't want to cheat, but
You
yeah,
could
but
probably
knowing that you ran an 8x8, so Michael, I bet if anyone had to pick a number, I don't know exactly what Doug is thinking, but I would guess 8 foot would be a good number.
Probably
know,
depends on how much room we have in the space.
Yeah, which isn't
Right.
much.
So maybe you could make a variable or different, some variables up there and change them according to whatever it is.
Michael, that's how I do it. I have a set. I was describing this last week. A set of sort of built-in waypoint lists, like a triangle, square, and so forth, and they're all scaled to 1. And then at runtime, I can multiply that by something.
Oh, cool.
I can decide just before I say go. I can decide how big a square to go around.
Awesome.
I will also say that this Foursquare was supposed to help people improve their navigation and their odometry. And really just doing it in one direction doesn't do that, because you can tune it so that it nails it going clockwise and you'd be 2 feet away going counterclockwise. So it really, a suggested rule change we've talked about is for next year is to require 2 runs, 1 in each direction.
Well,
One counterclockwise.
the thing about this is once I do this, I'll get a real good idea how everything works, and then I can go to the magnetic quadrature? How do they say that? Quadrature encoders.
You can do quadrature with optical as well. It's just an arrangement of sort of their phasing. So but I think you were talking about Hall effect encoders.
Yeah, those pollute.
Typically,
Maybe
those
we had some of them too, them quadratures. So I can just get this down and understand the concept, and then I can build on it for next year or something.
That's the way to do it.
That's the plan, yeah. But typically, the Hall effect are fewer pulses per revolution, just because of the nature of the thing. With the optical encoders, you get usually a whole lot more resolution.
So I'll put an option out on the table for Michael and anyone else who's interested, and that is that if you're not a Makerspace member and you'd like to try it out in the room on the floor, let me know, because I'm planning to head up there next weekend or this coming weekend and tweak mine a little bit. So David would like to go. Okay, Michael, are you interested?
Well, I gotta get mine. I gotta get my wheels rolling first. So
The only
I don't
problem
know.
will be is, Carl, you need to look at the schedule. Like for tonight, the room is being tied up with wood carving. Okay, so hence that's why I'm in this other room. So
I can
that's
get-
the only disclaimer I'll put out there. But there probably is a room available. Okay.
Well, I was just going to gather some names and see, names and times, and if you wanted to, we could arrange it. And
Yeah,
like, I found
I'm going to
mornings
be here a
easy.
lot. Let's put it that way.
Carl,
So,
Carl-
I'm like you, Carl.
your email's on the members page, isn't it? Carl?
Yeah, yeah, you
If I
can.
get far enough along, maybe I'll try and email you or something about
Yeah,
that.
that'd be fine. And I would suggest if we wanted a free and clear time, yeah, we could check the Makerspace calendar,
Right.
but even then to
Yeah.
avoid squatters, probably I would guess Sunday morning. That gives you Saturday.
And you might want to, if you want to pick a time, reserve the room.
Yeah, I could do
You
that
might be
too.
able to do that
Yeah.
because.
So we won't be squatters.
Right.
Well, yeah.
Hey, that works. Well, just let me know who's interested. So I got David and Michael, and we can chat. We can nail the time down.
I'll squat.
Okay.
I had a question about the remote competition, what time would be the best time to join online with Google Meet?
All these difficult questions.
So there is an agenda on the page, the link that Scott posted.
Yeah. I think Scott posted the one for Robo
Okay,
Columbus.
yeah,
I
that's
posted
Robo
the one-
Columbus in October.
I posted
Yeah, I
the
know.
first one, and there's no time for the remote. We'll have to ask Doug about that. Is there a time you'd prefer as our star remote participant?
No,
I mean, really?
I will be flexible, and I thought about joining possibly just before at 12:45, your last call for robot checks,
All right.
because you're going to do. I may join around 11, maybe, if you have it available for the robot weigh-in and checks and sizes and compliance and everything, and then come back at 12:45 or whatever for the robot check.
If you like, we can make something happen. I would suggest
You can mail me a pizza if you want to.
that we'll talk to Doug about that. It might get cold by the time it gets there. So I would suggest why don't we since you've already made the first entry of the competition, we ought to give you pole position on the agenda. I think we should just tell Doug.
All the weight's on you. All the weight will be
I
on
don't
your
have a
shoulder.
problem with that.
Unless you'd rather take the pole position at the end. Usually it's the middle people like in auditions and stuff. They want to either be the first or the last, not lost in the middle.
It's better to go first if you're remote.
There's the
Sure.
answer.
I can go remote, and then I've given you some links to some videos that were the middle of the run was accelerated. If that's okay, I'll keep those because it's quicker. But if you want to see the whole run with in regular speed, I can do that as well.
Cool. We'll
Kareem, why do you say that? You sound like you speak from experience.
When my team does hybrid meets, the people, once we get going locally, it's really hard to pay attention to what's going on remote. So we found it's better to do anything that requires remote interaction to do that first, because we can't like stop ourselves from side discussions and all of the other things, and you sort of lose track of who's online.
Interesting.
it makes a lot of sense because you really owe it to the people who can't make it there to give them some good floor time.
Yep.
Yeah.
I'm good with any time you want to put me, beginning and middle, doesn't matter.
Right. Very gracious of you, but assume we'll pencil in that you'll be the first in the line at the start of competition.
So you can crush the hopes of all your enemies.
That's right.
Exactly.
I don't have enemies. I just have co-competitors. It's like T-ball with the 4-year-olds. Everybody gets a participation award.
Okay, cool. I got some notes here. All right, cool. And then, so let's move the discussion along then. And I will, while we're doing that, I'll look at some times and just propose Sunday
Okay.
for,
And as far as I can tell, regard to the outright look, effectively only Tuesday evenings is the only time that room is being booked, because everything else is in like the north lobby and that. So I think any time will work.
wide open.
Yep.
Okay.
Pat, are you in the same time zone we are?
No, I jumped over your time zone, and now I'm an hour ahead of you guys. So the meeting started at 6:30 my time.
You're in the future.
Yeah, I'm in the future. So normally, or I'm in the past. Normally, my meeting starts at 8:30 your time.
And you can just arbitrarily assign yourself a time zone?
It's the way I am.
He's a time lord.
Exactly.
Uh,
I'm in mountain time right now.
Carl, I have a slightly robotic question.
Okay, well, why don't we stack you after John? He got in line a little earlier. So I think, so Michael, we got your question covered. Psyched up. You're going to do it, man. We're going to help you get there. And maybe Saturday or Sunday. And I only say that because that's when I can get down there. We can do something in person. And
Absolutely. Maybe y'all can give me some code pointers or something.
Yeah.
And also, Brini, is it your granddaughter?
Yes, my granddaughter mentioned to me the other day that she wanted to go with me and get involved in robotics, but
That's
she
right.
could just be bored because it's summertime. So, but
Well, she will no doubt lower the average age of this group substantially by her presence.
I know. So we'll see what happens. She's pretty sharp, man. She's in the honor roll, so she'll pick up on this stuff if she doesn't get bored. You know what I mean? So we're a very niche group for sure. So man, I hope she gets fired up because me and her we can do some stuff together.
cool. All right.
So to
John, what you
encourage
got?
you, there's those cheap motors. Okay, so and unfortunately it's very dark in there. But if you were to able to look down that hole, you'll see the encoders, and they're the magnetic type, so they tend to have lots of ticks, which is the part that surprises me a little bit. Okay.
How many ticks you got for that?
You'll have to look at the specs on the rib. I forget, but it's way up there. Or I have about more than that. It seems.
That's only 20.
So a lot more than that. But I'll pull up the paper. I have it actually on the drive, so I'll pull that up after. Hopefully, next step I was going to do is actually run it. So let me see if I can lower this down.
Oh, cool.
Like so. And then we'll see if this works.
Hey, does my air conditioned sound pick up?
Nope.
Okay, good.
You're probably hearing the fan here, though.
No, I'm just.
Hopefully not. Okay,
I just
and
don't want
then
noise.
hopefully this will. Yes.
I think I heard a 3D printer or something from John G.
Oh, I better. That's me. I'll silence.
Okay.
Hopefully. Okay. Yeah, it's gonna go off. Okay. Oh well. Little up. So there's where I'm at so far with it, but
Well,
but
he
that's
gets
an
a gold
example.
star, doesn't he?
He definitely gets a gold star.
So let me go grab it, and I'll be right back, and I'll run it one more time. Because the other time it was better than that, but
That was a full half quick trip.
You know that in the long ago, one of the mottos of the DPRG was, well, it worked at home. But you know, we really can't do that anymore because, you know, we're in your home right now. Show it to us.
okay. So there's number 2. It should do better, but for some reason it wants to go left a lot more than I thought. So I must have changed a variable recently that I didn't realize. Hence, but it tends to be at the same spot right now, so that's good.
That's really good. Are you
So-
just open loop, or you got encoders going?
I have the encoders, but it's trying to get the right range. It seems to be, right now I tend to be around 40 or 50 ticks off sometimes. In other words, it can go anywhere from 0 to 80 on either side. And
For the
trying to zero
you've done
in.
a speed loop.
Yeah, I don't really have a speed loop per se. I have simple code. I'm debating. I'm involved in the code. So
I got another question for you about that. How do you know that you're aiming your robot
okay. In other
correctly
words, And I doubt if you'll be able to see this picture here, but here's numbers. So that's why I said, basically I can say that there are certain angles and ticks, and when I was going at a certain speed, like 188 and 245, I would get 1481 2025 ticks for the S amount of time. So I have actually a real chart here I've been sort of playing with. So yeah, I've been thinking about involving the code a little more than that, but
I usually teach my students to do line following first. And once they can follow a straight line, that is their true, that's basically their ground truth. And then you see what the encoders from both wheels are doing. And
Oh,
you figure out from that what straight means for your particular robot. And that way, if something changes, because they do a lot of Lego robots when they're starting out, if something changes, something gets loose, something, the angles are a little bit off because some of the Technics connections are loose, then, if you calibrate every time before you run a competition, then you're golden.
Michael, was your question about how to orient it at the
yeah,
start?
how to orient it, like,
That's
not
always
going straight.
I have to show in this robot. Can you see? Yeah. I don't know if you can see right in the top there. There's a laser pointer right here, and it's in a little 3-point mount. I don't know if you can see that at all.
So you're using a laser on there.
So yeah, it's a little battery powered. Got its
Okay,
own.
I know from that.
And the way I aligned it was I would. It's on this little 3-point mount, so I can point it around. And I knew the robot was running straight, so I just pointed at the wall and see if I could hit the point, and then tweak that heading around. But
So what would you do? Would you like put a piece of, like, say you're in competition, would you put a piece of cardboard in front of you and make sure you're straight or something before you start?
Nah, I just pointed at the far wall. Let's see. There's a switch here somewhere. Let's see if the battery's still on. Nah, it's dead. But one thing I would do is I would rock the robot up a little bit, like this, and that would make the laser draw a line on the floor, so I could get a quick.
Oh, okay. Yeah.
But basically, yeah, that's always the problem. It's how to do the orientation, how to do the initial orientation. It would be nice if you had like sights, or you could sight across the robot.
Yeah, like a gun. Yeah.
I like to use in the building I work in 1-foot square tiles, which you can use like a big piece of graph paper. And what I do is put the robot down centered, so that the axle lines up with one axis and the center of the robot lines up with the other axis. And you can that's pretty repeatable. You want to run tests and so forth.
You can get
But
those line.
Another reason why you may want to oversize it from what the cones are actually set, because if you're oversized, it doesn't really matter if your square isn't quite running with the cones. You're still going to do your square and come back to the same spot.
Right.
Whether or not you ran square parallel to how the cones are set isn't part of the score, right? So you just look at what you have to do, which is really just come back to the same spot and not go inside the cones.
You can also get those lasers that project a line as opposed to a point, and that you mount the tools. You can get those on Amazon very easily. They're like $5, something like that.
Yeah. So that's a handy thing to have.
That's some good advice from all of you. I've got some of those little lasers somewhere. But yeah, appreciate the advice. That's going to help a lot.
So, have another thing to show besides that. So let me show you this all, because after the contest, this looks like a neat thing to build. So I saw this the other day, and they actually have a video now out on it. But what I like about it is the design where they put the servos. Because instead of having it down here in the bottom of the leg, they have them both up in the body. So it's sort of an interesting design how they did it. I don't know if this one actually shows you a better close up of the leg or not. And nope, I don't. Okay, but I'll run the video and you can sort of see how it looks.
John, can you put a link to that in the chat?
Yep, will do.
I got it for you, John.
Okay. Or actually, yeah, I'll enlarge it a little bit so get the full link above. But to me, the only thing is I think I would enlarge the legs a little bit to make them stronger because they look pretty thin to me, but just eyeing it. But I do like the fact that the servos are all up in the body, though, instead of down below. So, yeah, I thought it was it looks pretty, well designed. And I haven't really gone through this one, but I think he describes it all pretty well. Yeah, on the electronics.
Is it me or is the quality of these Instructables and things just increased over the years? I mean,
Well, some are, some aren't. I've seen some bad ones, so
yeah,
this one's pretty good, though, it looks like.
seems like more and more of them are. It's easier to find them like this, where they've really put time into it.
But yeah, this one he's definitely took some time to get it done right. I mean, yeah, from what I'm seeing,
How many servos does it use, John?
I think 4, because basically 2 per leg, so that'd be 8. But let's see, somewhere in here. Okay, well, he has 12. I don't know where he
Well,
gets
it looked to me like he had a shoulder as well that was pivoting in and out.
Yeah. Well, yeah, but right. Well, yeah, you have the one for this linkage, and then you have that one. So that's where I get 2, but I don't know where he
That's
puts
what
the
I'm
third
saying.
one.
When you showed the video, it looked like the shoulder was pivoting in and out. So that would be a
Okay,
third servo.
maybe. I haven't looked real closely at the bill.
It doesn't really
Actually.
walk very well, does it?
No, and that's why I said would make the legs stronger. I think they're a little thin is the problem. Well, let's see. Yeah. There's 1, 2. Yeah, there may be the third one. You might be this real linkage right there. Could be the third one, maybe. Okay, well, here's the leg. So, yeah, he has 3 motors.
See what his 5 more images were.
Yeah, well, I was thinking it was down below, but we'll see. Oh, he actually maybe have. Let's see what this one shows. Yeah.
You'll have to get one of those 3D printers that print titanium.
Yes.
Or at least Ron's carbon fiber one.
Okay.
So we're going to do that for all 12 of the servos, but I'm going to only show you how to do it for the first leg. So that's only 3 servos. It's the same for all the legs. So once you know how to do it for these 3 servos, you can do it for the rest of the night. All right. So let's get started. The first thing you want to do is
Swear.
plug in your illumination. And before you do that, there's one main thing you need to do, and that is you want to make sure.
Okay. I want to know is where are your motors?
and you want to mess with them full time.
I think the third one may be to push the whole leg out.
I'm thinking so.
Yeah.
Oh, there's one right there. And, okay, first one,
Yeah,
right?
that's what I was saying. There's a shoulder joint that pivots in and out.
Yeah.
There we go.
Ah, okay, that's where it is. Okay, so you have one to turn in and out. A good spot where you show it. Get there. Okay. So yeah, it's one for there, one to rotate the back left and right, and one to go in and out. So yeah, that's the thoracic. So yep, he uses 3 per leg. So that's how he can get that.
That's some complex servo diddling right there.
So yeah, so that's how you can get it. Cause yeah, it's eventually in the video he shows where it leans to the left and leans to the right. So yeah.
Well, they'd use that in rotation as well, right?
Right.
Yeah, to like put the, it's like the old mime thing,
See there, and that's where you get the third one movement. So yes, hopefully that's why before Clemens I can build that, but we'll see. Because this one looks pretty cool, and it looks like he's done a pretty decent job. The only thing is beef up the legs a little bit.
At the risk of starting a whole side discussion, I never got the idea of why you'd want a robot with legs. Wheels are so much better.
Amen.
We can't have wheels on us because there's just no way to articulate them.
Yep.
But if we could, would we go back to legs?
We got them as soon as we could.
Exactly.
Yeah, but you can go over rocks, over things.
Have you ever seen a legged robot climb something that a rock crawler couldn't? Ever.
Well,
Better than that, do you know what trials are? You know those guys on motorcycles that jump on top of boulders and stuff like that?
Right.
Those are wheels. I've never seen a robot come anywhere close to doing anything like that. When I brought this up before, and I'm sure Kareem has heard the same thing, it's always pointed like mountain goats and things like that. But the thing that's missing is the controller. That's what makes mountain goats able to climb those vertical surfaces. It's the brain and the sensors, not the actuators.
If mountain goats had wheels instead of hooves, they'd still be able to do it.
Gee, as long as they could.
Well, that's what I was saying. That particular robot, we should be watching a Boston Dynamics or something. That particular one didn't walk very well, and I imagine that's its software.
Well, even
also,
Boston Dynamics, I've never seen them like when they do demos of Spot going through,
Yes.
broken caves and things like that. There's still wheeled robots that can do the exact same thing. We're not at the point where any legged robot is going to be better than a wheeled robot.
Furthermore, they usually can't carry very much power, and often the ones you see on the internet actually have a cable running off of them.
Yeah.
To supply their power. John, isn't that right?
That tends to be the problem. Yep.
So is that a new term? A wheel chauvinist?
Absolutely. I'll respond to that.
At least at this point in time, the wheels can carry more weight, and as I say, I've got wheeled robots that can go up and down stairs and things like that.
I don't know about. I would disagree with that, Lil. I think there've been some out there that can carry pretty heavy. So
Compared to wheels, though, no. Most of the power goes to making the thing walk.
You put wheels on humans, but you don't put more feet on humans.
Well, maybe exoskeletons. But... And then there are those circus performers who do perfectly fine, I presume, on 2 legs, but they have to go put stilts on their feet and stilts on their arms and walk around on 4s.
Hey,
Yeah,
it worked.
right.
It worked as the drivetrain for Fred Flintstone.
So, well, Carl, this segues nicely into what I was going to ask about, which is basically, I don't want it to just be a conversation between you and me, but playing around with, as I talked about some time ago, watching ice dancers and ballerinas and how they can pivot around their center of gravity while at the same time progressing across the stage or going around in a circle or something like that, separate and distinct from rotating around their center of gravity. And I know you've got that working, and I do too. And basically, after a lot of thinking about it on a two-wheel robot, well, three-wheel, but a differential drive robot, the algorithm basically is that the robot is rotating around its center at some constant rate, and then it's being offset from that center. So if you think about the way if your robot is controlled by a velocity and rotation, like the twist command from Ross, then that does about half of the work for you, because you can rotate at a constant velocity. And then if you add, so you're rotating at a constant speed, and the velocity is zero, so you're rotating around your center. And if you offset from that just a little bit, then you give it a little bit of velocity, either positive or negative, you're no longer rotating around the center. You're rotating around a piece that's off a little bit from the center. No, I mean, just set that as a constant. So you're not rotating around the center, you're rotating at someplace between the center and the wheel, let's say, with both the rotation and the velocity as a constant. So now instead what you do is you drive, the rotation remains a constant, but the velocity you drive from the cosine of the instantaneous robot heading. And so as it goes positive, one wheel speeds up, the other slows down. It goes negative, just the opposite happens. And I actually have, let me see if I can drag this over here. I typed it up here earlier. Am I presenting?
Yep, coming up.
And there should be a, where to go? Uh-oh, hang on a second. Got some text there?
Yes.
Okay, so where theta is the instantaneous robot heading in radians, and KR is just a constant because we're going to rotate at a constant rate. And gain is the robot velocity along the path that we want to rotate along. And heading is our desired heading in radians. So there's a fudge factor, which I think corrects for latency, but I'll get back to that. So if you look at number one, the rotation is just set to a constant. So you're just spinning around the center. And then the velocity is just the cosine of the heading. And now if you do that, it's going to travel, well, if you started the robot off pointed north, it'll travel north, and it'll travel at a constant speed. So the actual algorithm I use is you take the cosine of theta plus whatever heading you want. These are all in radians, plus this fudge factor, and multiply that times a gain. So if the gain is zero, you just rotate in place. And as gain becomes non-zero, you begin moving in the direction of heading, even though you're rotating continually. So you can do accelerations and decelerations by adjusting gain. When gain is zero, you're still rotating around your center. You're rotating constantly around your center, that never stops. So rotation is just set to a constant. I believe fudge factor, somebody brought this up a couple of weeks ago and I went back and looked at it and I think it's correct. There's a certain latency between the time you sample the robot heading and the time and where you're actually pointed, because it looks like fudge factor is dependent on the rate of rotation. That is, you need a different fudge factor if you're rotating faster or slower. But I had to put that in. Say again?
Or in the other direction.
Yes. Yeah, exactly. So, and I had to put that in because when I set all this up, it wouldn't, if I said go 45 degrees, it wouldn't, it would go 40 degrees. And I had to add this fudge factor in there to get it to go the direction I wanted. Yeah, Kareem, as long as KR and minus KR are the same, so that it's either rotating clockwise or counterclockwise at a constant, then fudge remains the same. But if I increase the rate of rotation or decrease it, then I got to play with fudge. So as I say, I think that's correcting for latency. So, Carl, where I'm going with that is that how you're doing it?
Well, I would say that I'm not applying these equations. I would say that there's probably that these equations might describe what my robot's doing, but that there's a different set of equations that drive the behavior of my robot. And mine, as a reminder for everybody, uses mecanum wheels.
Well, I guess the question is, does it do this?
Velocity is the cosine of theta.
Where theta is the instantaneous heading as it rotates around. So basically, velocity is going to be a sine wave.
Okay,
If you're rotating at a constant velocity, at a constant rotation, velocity will be a sine wave.
I suspect that that's an equivalent description, but that mine might actually drive it differently.
It may not be. One thing you enjoy with the mecanums is they're not constrained by not being allowed to slip, like David's is, and you can probably get. The basic function of mecanums will sort of let you do this a lot easier.
But you see, I don't necessarily.
You probably don't have to have an offset center of rotation like David has to have.
I don't model.
Yeah.
Let's see. Actually, so let me put it this way. So let's say KR is a velocity rotation constant. Yes, I use that to drive it. I say rotate this many, whatever the units are per time. And then in terms of velocity, so let's keep in mind that for a mecanum wheel robot like mine, velocity is a vector, right? So it's got an angle and a magnitude. Okay, so for the way that mine moves in a straight line, even as it's turning, is that I know the absolute world heading because of the BNO 055. Okay, so I know where the robot is with respect to the absolute world heading. Okay, so I can calculate at what angle the robot is with respect to whatever angle I want to be going at. So then I know that, well, if I want to be going this way and the robot is aiming a certain way, then I need to apply a vector in a way to counter that and move it in the correct direction. So nominally I would apply the vector in a magnitude and direction that lines up with the heading, except for this lag factor you described. So I offset it a little bit so that I guess my command leads where it needs to be by the time it takes effect. And then in that way, the velocity that I'm giving it will have the same magnitude, but the angle is constantly changing. So the velocity vector is rotating for the mecanum robot just to keep it moving forward. Does that make any sense?
It does, and I think what you described when I said if you use a separate velocity and rotation, it kind of does part of that for you. And that's the part you're doing through the vector. So it's not exactly the same, but basically your velocity changes with your heading, and so that's what's happening here.
Yeah, the velocity vector changes with the heading.
Changes with the heading.
But I still have those two different controls, which are totally, and maybe your math is actually spot on here, because I do have those totally independent controls. I through one control change the rate that the mecanum wheels robot spins about its center, and then through another one, I say, okay, now I don't care where it's spinning, I just know where it is relative to where it wants to be going, thanks to its virtual orientation. So apply the vector to move it along the way.
And you're using that BNO 55 to give you your what's the update? What's the sample rate of that? Do you know?
I check it at 20 hertz.
20 hertz, yeah. So Carl, are you saying kind of the equivalent is rotation equals fudge and velocity equals fudge then? Or
Well,
I'm just kidding.
I just don't know about, yeah, okay, right.
It's all
Yeah,
a lot
no,
of
it's
fudge, right? It's a lot of fudge.
A lot of fudge.
Let's say my robots are kind of more of a rocky road, so.
It's all nothing but fudge. Is there is there an actual use for this? This is just a gimmick, right?
Well, no, it's because I was
Tell-
interested in
Tell
how,
me a real world situation where this kind of motion is useful.
well, as I said,
Enjoyment.
I was,
It's mathematically elegant.
I was trying to understand how ballerinas and ice skaters and ice dancers and so forth, how they do that and how that could be translated into a robot. So if I ever want my robot to dance, I've at least got some algorithms. But I'm 100% with you, Kareem. It has zero real world application. It's just fun.
It's just art. That's great.
Yeah.
It's fun.
Art
I will say I can do the same thing with my helicopters. And with helicopters, it's called stirring the sticks. So basically, you give some rotation, so the robots, the helicopter's rotating around its center, and then you watch the nose of it, and you stir the cyclic exactly at the same rate that the nose is, and you can make the robot, listen to me, you can make the helicopter go in any arbitrary direction. It's a little harder because you actually have to fly. You got to do that part, which you don't have to do here. But it's actually quite elegant to watch.
Those stunt flyers are absolutely amazing. What they're doing these days.
There's the real world application. It's entertainment.
Keeps me entertained.
To the point of writing algorithms down in equations. That's impressive.
Well, I thought a long time about how you would do this, and it really led me off down some deep holes trying to figure out. I knew I had to drive the two wheels out of phase with each other with something like a sine wave, but suddenly it hit me that I was making it way too hard, that the way the velocity and rotation are combined to give you a left and right wheel actually does part of or most of that work. It's real interesting to turn the gain way up, which I played with. So when you get the gain up to basically up to 1, then the inside wheel, as you rotate, comes to a stop. Okay, so if you get larger than 1, instead of twisting like this, it actually drives this little funny loopy thing like that. And that wasn't what I was after, but that's just as interesting to watch.
There's some funny things like that happen with my mechanical wheeled one as well. Because I put it up on the test stand, and I checked to see if it's working correctly. And if I hit that routine where it does the 4 square in spin mode, like the wheels are all doing crazy things. They're at different rates. The one wheel will stop, and the other one, I think, man, this is all screwed up. And I think, no, that's exactly what it should be doing.
Yeah, I can see it would be harder to understand what the mechanics. Yeah, than just with 2 wheels with 2 points of contact and so forth.
Yeah, but it's a fun challenge.
Okay,
cool.
That's all I have.
Okay, well, thank you, sir. Well, I have something, a kind of a follow-on that came to mind from Michael. Does anyone have a robot-related thing to jump in with after me? John does again?
I've got to apologize to Doug P, but he's not here.
Okay. So Ray, and then, but not Kareem.
You could apologize to us.
Yeah, I can do that.
Okay.
You can pass it on.
We'll pass it on. Okay. So what I have then is basically, Michael, you were thinking about for your great-granddaughter, and you're there. Yeah. Okay. So the one way is that robot. Now another way is like this one, the make block. I don't know if you've seen this one that I drug out before. Now this one I went and I took a Halloween mug and I gave it a facial which really screws up the weight in a bad way, by the way, because this thing weighs a ton. And it's good I didn't put out an eye when I was cutting this. It's really obnoxious plastic. But the bad thing is it doesn't have encoders. The really nice thing is that they're well made. They're easy to manage by 10 and 11-year-olds, and they're programmable in Scratch. And as it turns out, this one you can get, I think, for like $70. And then they launched not a year ago or less. They launched a Mecanum wheel one like this for 130. So, and the Mecanum wheel one is a Arduino Mega based. This is Arduino based, and the Mecanum wheel one has 4 encoders. So, in theory, I think for 130 bucks, you could get a platform very similar to the one that I'm doing this pirouetting mess with, and it's programmable in Scratch. And from my view, they've just done a fantastic job in making it accessible to do a visual drag and drop GUI-based programming.
Yeah, I would definitely get her something like that. I'm gonna see how she does.
Yeah.
If so, that Scratch thing sounds real interesting.
Yeah,
You know?
I mean, and if you, what we can do is, if you remind me, if we wind up making it to space, or just at least by RoboRama, I'll bring this with me and you can play with it.
Nice. Okay, cool.
Okay, I'll make a note to self.
I highly recommended
I noticed.
block-based programming for young kids. It's it takes all the worries of syntax out of it, and I've seen syntax crush interests like nothing else.
Yeah.
And so, yeah, highly recommend block-based languages.
I've actually played with some of that, that block-based kind of Arduino stuff. Online, they got them online. They've got those web-based.
The web-based IDEs, yeah.
Yeah, I've messed with them myself. Yeah, good idea. That's an excellent idea.
And I prefer they make downloadable ones. I think I forget which ones are better, but and then the other cool thing is that you can still, even though it's block based, you can still, if you really need or feel the urge or want, you can make your own module and create a block out of your module, and then your family member can just drop in your
plug it in. Yeah.
But they have a lot of modules available, which is also kind of nice.
Well, you talk about code crushing little kids. Sometimes it crushes a 66-year-old.
Carl, is that a user interface on top of it that you were just showing us?
Oh, this?
Yeah. What is that?
If you count lights, I mean, it has some status lights, and it's got some. I'd have to get the remote control to tell it what to do, but it's got some RGB lights you can control. It's got 4 I2C ports on this one, then a USB port. It's got somewhere it has a joystick. Yeah, it's got a little 5 position joystick, I think. It's also got a speaker or a crude beeper thing. So, I mean, you can run out of these I2C ports really fast, making up for the Arduino Uno. But on the Mega, I think you'd have more than enough I/O to do whatever you want to do. And it has this one has it has dedicated port for the motor connectors. It's got this lithium-ion battery buried in there. And it's got all these sensors that are readily available.
Cool.
Oh, Doug's joining. I'm going to be able to apologize.
Oh.
Yeah.
Those eyeballs are sensors, ultrasonic.
Yeah, these are just the ultrasonic sensors that happen to line up with the right size cup that I found for $2 at Target.
That's awesome.
Yeah, and duct tape heals all.
Yes,
Yeah, so this is Make Block, by the way. Make KE
Okay.
Block. Yeah. I can put some other links in there too, but
Yeah, thanks a lot.
No, it's well worth it. They're a good deal from my view. I got 3 of these, one for myself to coach, and then one for my nephew-in-law, and then one for a cousin nephew-in-law. So so we came up with our own little robot sumo thing, and well, it was good for a month. Well, maybe more than a month, because one of them dropped after a month, but the other one keeps adding like servos to it and a display and a speaker and all kinds of stuff. So he's exceeded the power of the Uno pretty quickly. It keeps going.
That's good.
Yeah. Yeah, and that's another thing. So like it's geared towards that age group. So the projects and add-ons that they have are very much age appropriate, and they're fun. They're just fun. But you get, like I say, you get something like the $130 one with the Mechanim wheels and 4 encoders. I think you could probably do some serious stuff if you put your mind to it.
I guarantee you, if she shows some interest in this, I'll do something like that.
Yeah.
Yeah, absolutely.
And that's another thing. It's easier on the coach, right? You don't have to go manufacture parts from scratch.
Yeah. No more 3D printing, right?
No, not anywhere near. You just have to sort through the infrastructure they give you and spend the time guiding your granddaughter.
Or machining, yeah. Something to be said for ready-made stuff. It's all
Yep.
ready to go.
Okay, well that's what I had. So I think next we have Ray, and then sorry,
Thank you very much.
you got it. Yep. I think next we had Ray and then Kareem.
Oh, I just wanted to show you some things. I don't know if you've ever heard of them or not, but I think these used to be made by Hewlett Packard. I don't know if some other company took them over, but they're actually like they start out HED and it's either S or W, or it depends on.
Those are optical
model
encoders.
Yeah, that's
Those are the same kind I have in my Pitman motors.
right.
There's a-
Yeah, and they're very good. I mean, you can get some really high-end resolution out of them. You know,
Yeah, the glass
I think
disc.
they may go up to. Yeah, I
I
think they
get
go up to, I want to say 2,000 pulses per
Yeah.
revolution, and the discs, like this is a
That's
lower
awesome.
resolution disc. And if you can see it a little.
Okay.
That one got damaged, but they come with, you know, different numbers of. I don't know if you can see the actual slits on that or not.
That looks like an encoder wheel from a industrial encoder we've used at work. Here you break
Right,
into them,
right.
you know, all those glass.
Yeah.
That's what it's like, isn't it? Okay,
Yeah.
cool.
Anyway, so you can get some really high resolutions. They come with, you know, different counts. You can get them, you know, 3-channel. You can specify the center hole. So I had these. Some of them Dave Ackley gave me, but I also had some. So like for the wheelchair motors, I had to make a kind of an adapter. It fits over the shaft that comes out of the back of the wheelchair motor, and then the other end here is where the disc goes on. So it kind of adapts to a smaller shaft that I had. And then I also printed holders for them. So it makes up the difference. And these 2 pegs are what the optical heads sit on. If I can get them in the right holes. Anyway, and you can set them up for whatever height you need, or you know, push it all the way down. And the center hole was to accommodate this chunk of brass, which is, I don't know what the diameter of it is, but it's basically fits in the center hole of this piece. Well, actually it fits in the center hole of another piece. This one was too small. Yeah, it's this one. So that actually fits in the center and holds the disc. And there's a little bit of space to rotate around with as it, it just sits on the back of the, well, it's actually glued to the back of the motor. But those are really accurate, and in most cases they're enclosed, so you don't have an external light source coming in.
That's one downside of optical encoders, is that they have to be generally shielded. Ray,
Right.
that looks remarkably like, here's a Pitman motor. Here's the piece you just 3D printed, and the
Yeah.
light cover, and that's your. Can you see it there?
Right.
That's your HED,
Yep.
and these are 500 count, I think.
Are they? Yeah. Yep. Yeah. They make some really high counts. And the other option, this is still in the bag. I don't know if you can see these or not, but those are the. Let's see if I can get the light right here. These are the magnetic discs. They have 10 pulses per revolution, and these are the Hall effect sensors here. A little printed circuit board from Polulu, and those aren't bad. But of course, you're getting 10 pulses on the A and B channels, whereas the other ones, you could have 500. So quite a bit more resolution on it. So I was fitting these to the back of these motors. This is the kind of the little platform piece. It's just kind of friction fit. If I can get it off. Well, anyway, just kind of looks like this. It's got two little mounts that have 2 holes on it. It just like a press fit on the back of the motor. If you can see it here or not. Anyway, so I was just hot gluing the magnetic sensor on the back of it, and had planned to use those. And if that didn't work, I was going to go to the higher resolution ones. And that's on. Well, this is here. But on this platform here, extend this out. Turn the light on so I can get. Here. Okay, so let's see, where am I? Okay, I guess I gotta switch cameras. Okay. So there are the 2 motors. I've got a one of the Ion Motion motor controllers. I've got an ESP32. Where's that? Oh, right down there. And then just a battery in the back. I had some success. I'm having an issue where this motor, it's on the motion control software, it's indicating that there's a short. So I don't know if it's an issue with the one channel of the controller or the motor. I've got to get another motor on here and see if it goes away, or if it is a problem with it. But anyway, so their chain drive, it's chain drive. The 2 the 2 wheels are just tied together by sprockets there. And so it's kind of left side, right side. And on the top here, I've got a B&O 055 and a little OLED display, so I can see what's going on. But I had connector issues. I crimped a bunch of the pins off the encoder, and that was just junk. I basically ripped it all off and replaced it all. I still have the short issue, and I've got some mechanical issues like these. I needed to stick shaft collars on the shafts, because otherwise the whole wheel, it can slide out, but it can also slide back in if it slides in too much.
Sorry.
The wheel is right here.
Sorry.
Oh, that's okay.
And it looks like we lost him.
Wheels actually
I was gonna
spin.
comment. He was saying, oh, no, there he is.
What's that?
We lost you, Ray.
Yeah, for a few seconds.
Oh, yeah. For the
Your
the
robot's
core
giving off an
Okay,
EM
so it's
pulse.
supposed to go. Oh, it is. Huh.
Yeah, it's completely canceling your electronics, connecting to the internet.
Ooh.
It's part of a plot.
You pull my leg. Anyway,
That's the tinfoil
let me
hat,
just turn it
please.
off. Anyway, so that's where it's at right now. It does, need basically the heading that the BNO 055, what it was and 180-degree turn and basically go back and forth in a zigzag pattern. And I can get it to do that, but still have an issue with the one motor and still have a couple of mechanical issues that I basically have to take it apart and put shaft collars in. So the shaft is strained in both directions, moving in. And right now it's just, it can only go so far out because the sprocket holds it in, but it can go inwards. It does actually, and I got to stop it from doing that. So, probably should put some nice assembling everything, but didn't think it would be an issue. I machined all these brackets to, to hold the motors down and to hold the bearings in place. I don't know if I'd ever do that again. It takes a long time. Anyway, so that's kind of where I'm at. There we go. I'm back on.
Hey, Ray, to hunt
What?
down, you said you needed a new motor, or you could just switch them, couldn't you? See if the problem.
Yeah, I
was
can.
and you don't even have, yeah.
Yeah, it's kind of a weird issue. It says there's a little flag on it's overcurrent, and it says it's drawing hundreds of amps out of the battery. So I'm not certain. I don't think that battery could supply 100 amps instantaneous. It's like a lithium-ion battery, but so it's kind of weird. I'm hoping it's not the controller.
Is it a 20C? 30, what C is the battery? I mean, they can.
It might be a 50.
50C? Wow.
Oh, it's a 45C.
Well, I would imagine that it could be easily, because what's the capacity? What's the capacity?
I think it's 4,500.
It's 4,500 milliamps.
Yeah.
And it's 45C. And it's 45C.
Yeah, you could weld with that.
Yeah, that's what I'm saying. That's, the batteries I use are typically, depending on how cheap I feel, are either 20C or 30C. 30C is kind of common for cars, but a 45 is for somebody who's serious. You know what I mean? Like David said, you could weld with that. That's 45 times 4,500.
4.5 amps, yeah.
So that's a lot.
Yeah,
big
but it's
number.
it's not really, I think if it was, it would be discharging a lot quicker than it is, but it seems to be holding up.
Hot. It'd be really hot.
Yeah, and it's not doing
really
that. So.
Hot.
You'd for sure know it if it was discharging hundreds of amps.
Yeah. Well, the controller get hot too, yeah. And it's not. It's cool.
The wires.
So there's something else. What's that?
The wires.
I don't know if it's. Say that again.
Just said the wires would get hot.
It would fuse.
Oh, that's true. That's true. Yeah, and they'd start to twitch too. If you've ever seen that.
Yeah.
Anyway, yeah. So
filter.
I don't think that's what it is, but I've got to get down to it. It may be just maybe there's something going on in the armature. It's I don't know. It's just weird, but you know, I've got to swap out something, and the easiest thing is I could take that controller and stick it with some other motors and see if it does it, or just swap out the motor and
Just
try
unplug
to.
it and put it. Can't you just unplug it and replug it on the other side?
Oh, the other motor?
Yeah.
Or switch sides maybe. See if
Yeah.
it follows the side.
Yeah.
Or follows the motor or whatever.
Yeah.
Yeah, that's another thing I could do. But it just all takes time, and I'd rather be working on, you know, smooth motion control versus all these mechanical and electrical problems.
Well, I tell you, for the competition this year, I'm simply trying to see if I can get back to where I was before COVID. That's what I'm trying to do. Because I got, you know the little base I've been working with. I fought all for a week to find out that one of the gears inside of the, those yellow plastic motors, even the ones with the encoders, the output gear is brass, beautiful brass gear, and it feeds right into this same crap plastic gear that they have. In fact, that's how I fixed it. I took an old one that didn't have an encoder, tore it apart, took the gear out of it, put it in the other one, exactly the same on the inside, other than that. And that was a bummer. Because it would work for a while, and then it would stop working. Yeah. And what was happening is, if the momentum couldn't get it through the bad part of the gear, it would just spin.
Yep.
And then I'd wiggle it around or something, or pick it up, scratch my head, put it back down on the floor, and it would go off. And I'm kind of like, what? It was really funky. So.
Yep.
So
yeah, and I sheared off. There's these little roll pins that attach the motor shaft to the output shaft in the wheel, and it's sheared off, but they don't completely. There's still a little bit of mechanical tension there. Yeah. So then you don't know. Okay, is it at first it looks like the motor's just not powering the wheel. Or not spinning enough. It is spinning, but it's also, occasionally catching and slipping, So, had to knock out the pieces of the pin and put another pin in, and, didn't have an extra pin, so had to wait to go to the hardware store. And it's like, all this stuff is, I still have a wheelchair platform, and that's pretty solid. It's kind of like a pre-built kit with big motors on it. I'm also going to try to get that going again, and that's what these I machined these brass pieces for, because their output shafts were, I don't know, like 8 millimeters, and I didn't have an encoder disc with a hole that big in it, so basically had to make an adapter for it. But the wheelchair stuff is very robust. Might have to hold up to a 300-pound person and propel them down the sidewalk or whatever through your living room. So they're pretty stout platforms. So.
Ray, one thing about those encoders is, you were talking about the Pololu encoders not being very precise, but that depends on your application, because those motors, the micro gearbox motors, are actually spinning pretty fast. That focusing rig, I don't know if you were on earlier when I showed the focusing rig I had for the camera. That one's got a gearbox with 1,000-to-1 gear ratio. So the output shaft is turning only about 11 RPM, but the But at 1,000-to-1 ratio, that means the actual shaft that the encoder on is turning at actually 12,000 RPM,
Wow.
right? You know, because, I'm sorry. Did I say that wrong? 1,000, sorry. 11, yeah, that's right, 11,000 RPM on the actual motor shaft encoder.
Mm-hmm.
So you got, and it's not 10, it's actually 12 possible states for the 2 bits of the encoder, for that quadrature encoder. So, so I mean, you saw I got from one end of the range to the other on that focusing mechanism. I had 1,800 state changes between one extreme and the other. So I can pretty precisely position the camera focus with that amount of precision without arrangement. But like I said, it all depends on your application.
I was looking up like the Go Buildas and the Rev Robotics. They only have like 7 poles, 7 counts per channel on theirs, but you might have like a 40-to-1 ratio on it. I haven't found a way to like Dave Ackley's method of doing like pulse doubling or the count doubling. I could do it out external within like an exclusive OR gate, but I haven't found a way to do that with the ion motion units. I don't think you can. Can you do it with the Rev Robotics, Kareem? You're on mute.
Not if using their standard API. I don't necessarily see a way to do that. They have dedicated encoder ports on their controller module that matches directly up with the port that's being powered.
Okay. Yeah. Yeah, so it's not bad. I think those motors, I think it's like 38-to-1 or close to 48 or 40-to-1 for the worm and the worm gear. So I do get, a fair number of pulses per revolution of the actual shaft. That's not bad. But
yeah, a typical Pololu gear motor, if you look them up, they'll claim that, and they are about almost 4,000 pulses per revolution.
Really?
Well, that's because of you're on that's the whole advantage of putting the encoder on the motor shaft.
On the motor, yeah. Huh, so they have some pretty high reduction ratios then for the gearing.
Well, yeah, but I mean, I think the ones I'm using are about 3,800. I mean, 3,800. So.
Oh, pulses per wheel.
Revolution. Yeah.
Revolution, yeah.
Yeah, and if you look at the wheel, that if you look at the circumference of the wheel, it means that you're getting like one pulse is it's in sub-millimeter. I don't know if it's in microns, but it's really small.
Yep.
So,
that's more pulses for that amount of travel than we typically get on the Rev and the Go Builder stuff.
Yeah.
Yep.
But we still get more than enough for pretty accurate positioning.
Yeah, I actually use one of those 2 channels to measure direction. So I'm in my code, I look for the falling edge on just one of the outputs.
Right.
And that's what I do. Then I look at the state of the other input and to determine if I'm running clockwise or counterclockwise.
Right.
So
it's like on a rising edge. You look to see if one is high or low, but you can also double it just by exclusive ORing in software. The 2 inputs together, and you get basically double the count with direction.
Well, you can
quadruple it.
If you trigger
quadrupling it.
Yeah.
If you trigger on the
I thought it was just doubling.
Triggering on each edge.
Trigger on the rising and falling edge of both pulses.
Oh, okay.
So
it's quadrupling it.
Yeah, so when
Yeah.
you trigger on the B channel, you read the A. When you trigger on the A channel, you read the B.
Yep.
And it's just Dave, actually, are you really there? I've never seen anybody sit still that long. Plus, it says you're unknown. You can just, I believe it's just an exclusive ore of those
I
four
think so.
channels.
Yeah.
Gives you
Yep.
direction.
Yep. Yeah. So I think with the Rev and the ion motion controllers, if you do it external,
Yeah, it is just an exclusive or I finally got my microphone working.
That works.
yeah, versus doing it in software because you don't have access to it inside those controllers. But anyway, so battling mechanical and electrical issues.
Worthy battle.
Carl,
What's
Good
that?
progress.
yeah, it's good product. Carl, can I make a little statement, or who's in line?
I am.
Kareem was next, and then it might be
Okay.
you could go right after Kareem. How's that?
That's great.
And then welcome, Harold. Good to see you. So I think that takes us to Kareem. Are you ready?
Yeah, I was here to apologize to Doug P. We're not going to make it. There's no way we're going to be able to do the locator challenge thing. It's just not working out. My team has first of all, they didn't want to just be an exhibition. They wanted to compete against somebody. I'm not that way myself, but they wanted to have somebody to compete against. But then, just summer travel, loss of a lot of seniors. And the final death knell was introduced by me inadvertently. I rented a piece of equipment to start clearing some land on our property to build a workshop to rival Michael's, and hopefully exceed it a little bit. So, the gloves are
Gotta go
out.
big, much bigger.
I thought he was going to throw gas prices into the mix as well.
Yeah, we're looking at a couple thousand square feet, hopefully. And
Cool.
so I rented an excavator for a month. And if you have an excavator on the property, then
You better use it.
yeah, you got to use it. That's got to be where our focus is. And
Yeah.
and it also makes for some nice experiments. So these are some of my miscreants right here. And I am in the piece of equipment.
Are they all gonna scatter?
You'll notice I don't have my hands on the. Yeah.
Oh, that's hilarious.
Can't turn right. There you go.
Oh, you're doing it with your feet?
No, they're doing it.
We both.
Oh, they're doing it.
Yeah, my feet are solidly on the floor and my hands are not on the levers.
Oh, okay.
So in
Damn, that is risky.
So we also beat Ray out in terms of scale right there. So that's a 4-ton excavator.
Yeah.
It's a 4-ton excavator. I haven't counted the degrees of freedom on it. The next step is to see if we can actually control the arm itself, and that's.
Have you tallied the number of safety violations?
You know, is it OSHA that governs this? I don't know. It's on private.
Yeah.
And,
Yeah,
and
it's
and
with
it's
the
not
OSHA because it's not a business yet.
It's not. Yeah.
Yeah, and Kareem, you're the safety operator, right?
Yes, I have my. There are 2 safeties, and one disengages the hydraulics, and the other kills the motor.
See, how can that be more dangerous than a self-driving car, except much more deadly and heavier?
It's like watching an episode of Mythbusters.
Well, a wonderful use of cable ties.
Exactly. Yeah. Yeah.
So Mythbusters, are we going to see this excavator blow up? Oh,
Well, that would be nice. Yeah, we got to take it to the local quarry and yeah, put some C4
So, did
in
you
it.
actually modify something you rented?
Yes.
No.
No,
Ooh.
I did not. We did not.
There's no
this is
mention
all
of the rental
sleight of-
agency.
This is all sleight of hand, right? This is all video editing to make it look like.
It sounds to me like a gold star, regardless, because
Absolutely.
Yeah.
Yeah.
It's a moving robot. It's not really autonomous at the moment. That was all joystick from their little joysticks, but you know.
a couple of sensors.
So, does the thing have a remote that it came with?
No.
No, it's just
No. We attach. These are linear actuators
Yeah.
attached to
the arms.
the
Foot
arm,
pedals?
the foot pedals, which are sort of I mean, it's you use either the foot pedals or the levers to control the
Right.
tracks, and it's just
Okay.
regular tank drive.
Yeah.
We'll call
So-
them muscle assistants to human muscle. How about that? Because your thumbs.
Yeah, there you go.
It's just an extension of their thumbs.
That's all
right.
it is.
That's right.
I think this deserves much more than a single gold star. It also deserves to be hallowed as the largest, heaviest robot ever demonstrated at the DPRG.
He gets an iron star.
All right. We get an iron
Right.
star.
Made out of 1-inch plate.
Did anybody else get a gold star today?
Yeah, John did.
John?
Show off.
Okay.
John, and we didn't formalize it, but it seems to me that John K did for his half a cook trip, and then John G had a working mechanism to toggle between day and night on a focus mechanism.
And
So
he
three today. Cool.
Yeah.
Well, Kareem, it's pretty understandable to see how your team might have been just a wee bit distracted.
Yeah, it's like you got to take advantage of it while it's there. And it just happened to overlap with the time period where we would be preparing for that tournament. So, yeah, but I do have. Oh my gosh, did I?
That was
I might have misplaced him. I have your. I have this guy hostage.
Okay.
So.
No.
Well, I've got another one.
We're not going to let you. Oh well.
I have another one.
Do you have another competitor though?
Well,
I
not
this
this.
cancel
I
this
doubt we're
time?
going to have it this time. But
So,
you
so
know,
we just
here's
free-
what why I'm pushing for this is I really would like to see us have a robot with some sort of AI component. Okay, and what?
That was
not
just
a-
bad timing. We would have tried to. We would have definitely done a run at it.
Doug, when you say AI, are you using that as a shorthand for neural net?
Probably.
Modern machine learning, I'm thinking.
Probably
is
because
classic.
I guess what I'm discounting is blob detectors and
But I
things
mean,
like that.
all our robots have some form of AI, right?
And the donkey cars had neural nets.
Yeah. Okay. We did do donkey cars. That's probably. I guess what I'm really saying, Dave, is, I'd like to see us get these Oak D lights put in. See some people using them, or some of the other or some of the other ones like the Maxi Bid or the one that what is the one, Ray? Opens? Is it open source? What do they call the one that's
OpenCV.
Open CV? Is it called
No, OpenMV.
Oh, OpenMV. One of these modern sensors that are now nobody can really say they're too expensive. It's just we just can't seem to make that get over that, because it'd be cool to see how, I think it would open some doors for us and make some things more robust than they are. I might be wrong, but it's time. So, like I'm saying, that's the thing I'm shooting for, is to use my my Oak D light on my rover this year. That's what I'm really shooting for.
Well, I just started reading my book, Neural Network Projects with Python.
Yeah,
So I'm definitely developing an interest here.
yeah. So, and I think that, you know, I think a lot of my questions, I'm sure if I knew somebody who had already been successful at it, they could give us a 1 hour talk and it just, you know, be just in. So, oh, no wonder I haven't been doing it, because I've been trying to do it this way, you know. It just, I think they could really make a big difference if we could get somebody with some expertise on that.
Are you talking about with OpenMV or any of the neural network technologies?
Yeah, I'm talking about the whole concept, the whole workflow, or otherwise selecting creating the data sets and learning, you know, training the model, setting up the models. Most people don't set up the models. They just use an existing model, and that's fine. I don't know enough about it to try to develop my own model when there's such good models already out there. And then they just train it. And, you know, then there's the option of some people can change the classifications and just train the back end of the model. And that's even supposed to be easier. But, you know, in a sense, I'm sure we did that in Donkey Car. All right. I'm sure we did that in Donkey Car, but
this book here actually it's I found so far it's a pretty good introduction into neural nets, and it starts out simple and works up to more complex models, but it includes the process of the whole workflow, including training. If you want to
did it cover the like I say, the one that the video Pat showed 2 weeks ago, you know, where the guy just told, I mean, that was a very practical, you know, all these things that people do, and I've done them when I've tried to create data sets, you know, where you make these like I guess they're beginner mistakes. And so that was real helpful. But I'm curious, the books that I've read never really get that practical. Okay. And I guess you really need to do that. I think the person who could probably, it'd be interesting to see if we got, God, I can't think of his name. The gentleman that was, did that contest, and he did a presentation.
Oh, Ross Melbourne?
Yeah, no, not Ross.
Jesse Brockman.
Yeah, Jesse Brockman.
Worked fun desk.
You know, when he's not competing, okay? So it'd be interesting to know, okay, could he take us through a practical building of a more practical, you know, before he was kind of like, I'm going to keep this secret because I'm in a competition. All right. But now he's not in a competition. You know, I'm curious if he could enlighten us more.
Well, I guess it depends on what you mean by practical. This book I've got here is based on projects that you can do.
Yeah.
And so he goes through, and just to give you a taste here, the simplest example he starts out with one is when they take a data set of medical data and they predict diabetes with a multi-layer perceptron. That's one type of,
okay.
That's a mouthful. That is one type of neural network.
Yeah.
Then he does an exercise where he predicts taxi fares with a deep, what they call a deep feed forward network.
Mm-hmm.
So that they actually use taxi fare data from New York City in that project. And then he's got the chapter I'm about to get to, Cats versus Dogs, Image Classification Using Convolutional Neural Networks.
Yeah, that's what I'm mostly interested in.
Yeah. And he gets into, these are progressively more complex as he goes, removing noise from images using autoencoders, sentiment analysis of movie reviews using LSTM, implementing facial recognition system with neural networks. And that's it. That's the 6 projects he's got in this book. And he gives you code for all of them and shows you what he's doing, what each section of code does, and how it supports the workflow. So far it looks like it's a pretty good book.
There's just a lot to cover, right? Because it's not one simple singular equation to master. It's not the PID loop discussion, right? This is a whole category of art with different styles of classifiers and recognizers and predictors and implementation styles and workflows and tool sets.
Yeah, and in terms of platforms, all you need for this is essentially is Python, and they provide the resources on a website for the data that you can download to perform the projects. And you can also download all their source code as well instead of having to type it in from the book. And all they use TensorFlow, Keras, and TensorFlow for all these projects. So they're not like out to show you all the different technologies that you can use. They pick one and then they use that to demonstrate 6 different projects that you can do with TensorFlow and Keras.
But there's even like we keep talking about images when we talk about these neural nets, right? But there's other kinds, because if you take this Kickstarter watch that I got 4 years ago, and it runs TinyML in there, so tiny machine learning and neural nets. So it actually has examples that teach you how to make a neural net that detects movement gestures using the IMU. So you can make an IMU gesture that recognizes this versus a swipe. So you can say, like that means raise the volume, lower the volume, or turn it off, and you can recognize those different gestures based on raw IMU data using a neural net, and you can do it in a watch. So it doesn't have to be images at all in all the workflows that we've discussed, like we use for Donkey Car.
Well, Donkey Car is a pretty interesting project because it takes the 2 scalars of speed and steering, and adds that to the images and predicts. And so that's a little different than one is just image, an object recognition. So there's some good stuff in that project too that is worth probably digging into eventually. But
right, and it's very easily taking like 10,000 pictures in just a little training that you do. So
yeah,
it's not like you have to sit there and pose something and say, okay, this is what this is. Here's a little shot. Here's
if you're gonna train your own, coming up with the data can be a real challenge. But if I use any of this for my license plate reader, like for example, for say recognizing license plates, but not necessarily reading the text, I can easily generate. I say easily. It would take several days, but I can generate thousands of images for training.
Dave, he's right here, right on your forehead.
By the way, I posted the title of that book in chat. It's available on Amazon.
Great, thank you.
Good review. Yeah, thanks.
Yeah, I was going to say, Carl, your watch could probably determine ethnicity. Like if you're Italian and you wave your hands a lot. It's
like my father-in-law, I would recognize right away. Yeah.
That's right. Yeah. It says, oh my God, this guy's an Italian.
At least he claims to be.
Does anybody else have that feeling that there's a giant crocodile coming down on us?
Giant crocodile.
Nobody's getting the reference to the tickings that's coming from
Peter Pan?
Oh, from Doug?
Peter Pan. Yeah, I heard they're ticking. I just thought somebody was punking us.
We thought we were on 60 Minutes.
Well, you guys are still here, and I've got 1 clock running right now.
The loud one
clears the bell.
Well, let me see if I put it over here. Now, is it gone?
Yes.
It's definitely
Yeah.
quieter. Yeah.
Yeah.
Okay.
Oh no. No, Carl's in on it.
I will, about that book, one of the things I will say is it's a fairly complicated subject. And so in the early chapters, as I'm reading the book, he'll say like, okay, I'm going to pick 32 nodes for this layer. I'm not going to tell you why, because it's too much for now. And he gets into that, he's going to get into that later into the book as he gets more and more complex. Then he'll explain why you would choose a specific number of nodes in a deep neural network for each layer. So
That was too soft, David.
he tries not to overwhelm you all at once.
Oh, there we go.
Curse
What is
whoever
that
made me
thing?
do that. This
Did
is
you
not
redo
too
it or
loud.
something?
Drive me batty.
Rain stick.
Oh, ranks.
A big one.
Is Australia where they make those?
This is from South America.
Yeah.
Basically, it's a cactus, and all the spikes have been driven into it by the person who made this, and then it's got pebbles in it. So what you're hearing is those pebbles hitting those cactus spikes.
Steve, now there's another item where at some point someone asked, what's the practical purpose of that?
White noise. White
Nice
noise.
noise.
The primitive white noise generator.
So, back to the subject. So, I wanted to show off this. So I found this, so y'all might like to look at it. And it goes back to about whether or not to have wheels versus legs. So,
Our latest religious discussion.
yes. So here's a two-reel, which I can see being better. So you might find this of interest.
Oh, it's a bicycle, yeah.
Okay. I thought it was more video than billing. Okay, so yeah, he shows that first. Oh, there it goes. Okay. So you put that on that. So yeah, I could see something like that. If you could only jump up, might work, but. Can eventually.
That kind of works against the concept of a bicycle because you want to
Yeah.
lean to create a turn
Yeah,
while you're
but
moving.
somewhere out there does movement. So yeah.
Can it turn?
Yeah, and eventually I think in the video he shows that a little bit. Yeah, there. Yeah, you can see the wheels moving. So.
But you're right.
So isn't it using precession?
Looks like it doesn't lean when it turns.
Not much.
It looks like it also doesn't have any caster in the front. It doesn't have any rake in the front wheel fork.
Oh, you're right. You're right.
So it's not a very good bicycle.
But
It's a lot better at standing still and not falling over than most bicycles are.
I like the simplicity of it. I've been thinking to build one of these for a long time, but now I don't have to because I've seen
can't
someone
say
else do
this
it.
is simple.
Well,
Not
Relatively
really.
simple.
no, but I'm talking about from the just look at the simplicity of the mechanism. I mean, there's not that many parts to it, and it's cheap parts at that.
Let's see the ping pong ball juggling robot.
Which. Yeah. Where was that? Okay, we'll have to.
Oh, I'm just teasing, John.
Oh,
That was
good.
last week, wasn't it?
He was actually going to show you one.
They're there.
So, which one is oh, that one? Okay. Since I'm curious a little bit. They're going to have an advertisement.
Oh, that's what we were talking about last week, that you should be able to catch with just a flat plate.
And they're using, well, I guess, who knows what, OpenVC or something, but
Basically, they're using a touch screen. So when the ball hits the screen, it gets a recording. Kind of cool.
Well, that's
Like a
interesting.
3D
They didn't have to use
on a
cameras at all.
okay. So they do have some sensors to see where it bounces.
Oh,
Okay.
So it's not a touch screen.
no, no.
No?
I thought that was perspective. It's just bouncing the ball,
All right.
keeping it on the paddle.
It's really not juggling. That's really more like, what's one of those, a little paddle with the rubber band and the ball?
Yeah.
Yeah.
Okay, so they use 3 servos, 2 controllers.
Well, that would be neat to see that too, right? A paddle robot with a paddle ball.
Kareem, I don't remember if you were here last week. Did you see that with the tennis players catching balls with their tennis rackets? They can just catch them. Evidently, it's a skill.
Yeah, I've done that. We can, yeah. I mean, I used to play tennis, and I used to be able to do that.
Okay, so we were talking about, we had a video of Federer and of a Nadal catching, and it never touches the rim. It's just that they're able to decelerate at exactly the right speed and exactly the right angle, and the ball just comes to a stop. So we were saying you should be able to catch a ball without having to have a hand, just by having a flat plate, if you know the trajectory.
If you can match the speed, and, yeah. Did you see the one that was recently released by the guy who's been doing all of those basketball hoops, moving basketball hoops?
Nope.
It's amazing. Let me see if I can find it quick.
We had the moving dartboard.
But Carl, you're right. There's not many parts to this bike. It's like, yeah. Not many. Surprisingly.
So I'm assuming the thing on the bicycle is just a gyro?
It's a reaction wheel.
Yeah.
Yeah, basically.
Basically a gyro, yeah.
But he also has to know the angle in order to know which way to spin the reaction wheel. So there has to be some sort of IMU or tilt sensor or something.
Yep.
But you know, that's how all the satellites control their orientation.
But there's the get hub for it. So.
So yeah, I was the stuff made here guy. I'll paste it in the chat. You guys should really take a look at this because it's in terms of control theory and stuff like that. It's pretty amazing what he's done.
Is that what you just pasted in?
I just pasted in, yeah.
Oh, you did a different for me.
This is very the latest version of his series. And you want me to show it real quick, or are we still looking?
Sure, why not?
It's a long video, but I'll just show you a couple segments from it.
Show us the best parts.
Well, I don't know that I have them properly queued up. So, but he says it's a 100-mile-an-hour hoop, right? And it is definitely fast.
Right. This hoop can move in 3D to correct your lousy. When it's all done, this thing is gonna sink all the shots.
Yes.
Well, except for the ones my wife shoots.
Was that supposed to happen?
This hoop is the conclusion of an arms race between me and...
So he always does very detailed explanations of all of his methodology. without getting into completely the nitty gritty details. And he's good at showing his fails. But let's see if I can just find some.
Wonder if it could go for a fly.
It's
Swap the
literally more
flies.
impressive if you miss.
So he's actually talking about how he thinks he can get it to move fast enough, or sort of anticipate enough so that it could catch the ball once, and then after it goes down, back off and then go under it and catch it again before it hits the floor.
Wow. So this is sort of a 3D version of the one we saw last week where the dartboard moved around.
Yeah,
So you always hit it in the center.
yeah.
Very cool.
Must have some awfully powerful motors to move that thing that fast.
He said that these are like they can move almost 10 times faster. They're giant. They're giant motors. They're way bigger than he needed for this project, but that's what he had on hand. So yeah, they have much more power than he needs.
Is there a vertical line? What keeps the board from flopping back and forth when he moves it?
It's 6 degrees of freedom. There's 6 different cables attached to the backboard.
I'll have to see that on YouTube. I can't quite see them here.
Well, it looks like,
Yeah.
and it looks like some of them are angled forward and some are angled backwards.
Yep. Mm-hmm.
It holds it very stout, it would appear, just from the, I mean, it gets in place well in advance of when it needs to be.
Yep.
Well,
He's got
like the cameras that they have in the football games.
he's using a motion tracking set of cameras. There's probably more than 6 cameras with infrared projection on them, and is tracking these little round balls. In fact, he tried to use you can also use these flat patches, but they don't give as good of a spatial solution as the balls, the reflective balls. So he ended up having to modify his basketball to create pockets in it so that he could put a full ball inside, and yet have enough of it exposed to enough cameras that it would get a solution. But that I think he said his cameras can create a solution within a microsecond. So pretty awesome. It's a high end rig. It's not. Yeah, there was some money there.
Well, what began all this discussion last week, Kareem, was that we were talking about how basically like the Hawkeye systems like they use in tennis tournaments, they're going to now start using in the minor leagues next year. And so basically the umpire will just have an earpiece that tells him whether it was a ball or a strike.
Yep.
And so we were talking about that.
I wonder how McEnroe would have dealt with that.
Well, I must say that there I am.
You can't be serious.
When I watch the tennis matches, what I notice is that the Hawkeye system, there's a latency. The human judges call the ball as soon as it hits the ground, but there's a certain latency, and so the players play on as they should. But that means that every call seems late to me, and I think it's kind of weird. Also, it doesn't make much sense to challenge the call, since all it's really going to do is show you the video of the decision that it already made, unless what you're really doing is trying to get a little time to catch your breath, which I think is often what they're doing when they challenge a call. So that we started thinking about it, how many cameras. Evidently, there's lots and lots of cameras involved. It's not just 2 or 3 like I thought. It's dozens.
I can't imagine what professional referees must be thinking of all this.
Well, the article I read about it showed a batter pretty sure, it was a ball right at the edge of the plate, and he was pretty sure that it was a ball, but it was called a strike, and he turned around to the referee and said, "Are you really going to call that a strike?" And the referee said, "I have no choice."
Yeah, there you go. Argue with the machine.
So the referees will be more or less just ceremonial.
Kind of what it sounds like. They still have to have an apron full of balls, and they still have some functions.
Well, I've seen some football plays where it was so close that it's like, you know, you think, man, they should have had some kind of computer system, you know, to call that one. And there's always going to
Probably-
eventually be a call that even a computer can't make.
Well, Major League Baseball will have to find something for all their referees, you know, to do now in the future that, you know, they won't need them soon here. So retraining maybe.
You got to have somebody for the players that are mad to come up and bark at.
Yeah.
What happened to Carl? Have we exhausted our queue of people?
I don't know. Carl left, but I wanted to say one thing for this thing happening on Saturday. If you look at the website, it gives the schedule, and anybody who could come early and help set up, really would appreciate it. Because I go down there and it might need to be swept and cleaned and everything. So I just wanted to make sure everybody who has a chance to come early, to please come early and help with the competition. Okay, that's
Yep.
what I wanted
That's
to say.
this Saturday, right? Or next Saturday?
This Saturday.
This coming Saturday. Okay.
Yeah.
You referring to Roborama?
Yeah.
Right.
That's the next Saturday.
I thought Roborama is a week and a half away.
No, I don't think
On
so.
the 18th.
Yeah, it is.
I thought it was 18th. It's
So
the
not this
18th.
coming Saturday, the Saturday after.
Okay.
Yeah.
I don't know.
I don't know
Boy,
that it's going to matter that much.
Well, that gives me a little more time. That's good.
This Saturday, this weekend, Carl was talking about getting a little bit of space up there to do trials and stuff like that.
Yeah. Yeah.
So David's brainstick brief demo made me think of something else here. It's completely non-robot related, but you got to see it if there's nobody else in line.
Okay.
So let me bring this up real quick. We're going to talk about music with unusual instruments.
Are they beer bottles?
Mm-hmm. It's the body motion that really sells it.
These guys are good. They're doing little slurs. They're good. Okay, quick. Kareen, what's the real world value of this?
It's infinite.
A plus.
There you go.
Think about that. These guys had to get together. They had to tune their beer bottles. They had to rehearse.
Had to fill them all up to the right level, or drink them down. I don't know.
Yeah, that would be empty them to the right level.
Empty them to the right level. Yeah, there you go.
It's all fake. It's just video processing.
Right.
Well, that seems like a good place for me to sign off, gentlemen.
Yes. Okay. All right. So it's the 18th. You're right. I don't know what I was thinking. Probably just
Got a whole extra week.
You got a whole extra week.
Well,
hey, Kareem, you got an extra week.
Nah, I'm still gonna have the excavator for that week. So
Okay.
yeah.
No, I'm just kidding you.
Yeah.
But keep the troll and plan for
Okay.
the next one.
All right,
'Cause
we'll do.
you guys have probably got a lot of talent towards that sort of area. I think that'd be good for you. Good challenge for you guys, so we can get a competition.
It would be a good challenge. Yeah.
Yeah.
So David,
Hey,
Michael,
well, here's
reach out
another
to me
thing
for the
too.
weekend.
Not this time, but Graham, you could invite one of your arch enemy teams.
Oh yeah, yeah, sure.
Okay, just a thought.
That's a good thought. Yeah,
Yeah.
To make
you
it
could
easy.
you could say, here's the challenge.
that would spur them on. Yeah.
Yeah. Okay. And then
Okay.
see what happens. Okay. Well, I guess I'm going to sign off too then.
All right, guys.
Guys,
Have a
Hey.
good night.
right.
Michael, send me your contact info and we'll set up for this weekend if hopefully.
Yeah.
Okay.
If you can descend from orbit and make it to the makers. Yeah. All right.
No,
Right.
or I'll be here. So
You're
I'll
really
be
busy.
seeing you all them. Especially if you're aiming for a Sunday or maybe even a Saturday.
Okay, put you on a list you want?
Well, yeah, well, just give me a call. You have my, you have the
Okay.
phone number, right?
Yeah,
But
I'll
yeah,
put you on the list. All right.
because I was planning to be up here anyway on the weekends.